My name is David Gruskos from RAE and SCRS board member, and today the Society of Collision Repair Specialists will be presenting spot welding. You know, if we had to say, a lot of guys will grab a welder, just walk up to a car, pull the trigger, and because they have a dot on both sides, they say that's a good weld.
Well, again, it's about training, and we talk about doing a destructive test on practice metals. What you want to do is put it together. I mean, it's sort of I'll say not a sophisticated way, but it's a good way of measuring it, is that we're going to do a peel test. We're going to peel that back, and then we're going to measure the diameter of that nugget that's coming off. And the rule of thumb is that it should be 5 times the thickness of your metal. So if you're using 1.2 millimeter thick metal, you should pull a nugget about 6 millimeters in diameter.
So you're always doing a test weld.
Right. I mean, why I'm putting all my faith in a piece of equipment, and you don't always want to trust it. Even though it says it's good, there's been instances that I've seen that the welds were no good. So just to protect yourself and the shop, do a destructive test and make sure that you have a good weld. So if you come out and it's too small, you're going to increase your amperage and your voltage.
Now, Kye, I've also seen where guys will just make a weld, they'll take a chisel and just tap the weld on the car and say, okay, those welds are good.
I haven't seen that, sorry.
Barry, yourself?
Well, no, I haven't seen that either. But that's a good example. You know, when we buy the machines, there are people that are in sales and there are people that support it. True. Okay. So I think we all can agree on. Unfortunately, a lot of times the folks in sales try to, hey, just set it and go. Hit the button, and your welds are going to be right all the time. That's indicative to Toby's point that still doing the destructive test, to test your weld before with the material you're using and see if it does. I mean, he came up with, again, you know, he trained us on that, to look for that in the example he used, the 1.2, the 6 millimeter nugget. That's one thing that, again, sales tells us, oh no, just hit the button and go. But in reality, we still need to trust but verify what all the equipment in our shops are doing. Because ultimately, you know, the owner, the manager, the technician now, because again, there's been some calls on technician liability as well, that we're all responsible and accountable to make sure that our equipment is working and that our technicians are properly trained in order to pull it off correctly.
You know, I have frequently seen a person makes a weld, and to make sure it's a good weld, they hit the trigger a second time
Right.
or a third time.
Twice as good.
From the education I've had on heat on metals, the heat that took to make that first weld would be the maximum that panel could take.
Yeah.
As soon as you put the second heat on it, that has now destroyed the characteristics of the metal and it's going to crack. You know, if you put a third one on it, you're just speeding up your cracking process. But, you know, Kye, in your shop, you do go through the proper destructive test before you fix the car, and you do take that extra mile. I think that's like, how much longer does it take you to fix a panel than the next guy?
Well, you know, I have to say that to do a test panel is your due diligence to perform a proper repair. But let's take into consideration real world. So you're putting a quarter panel, let's say, on a car, and the panel that you use as a test was a certain size panel. Well, as we all know, down below, when you're spot welding, you could have 3 panels. You can have a rocker panel that's a thicker gauge than the panel that you did a test panel on. So you can only do so much to ensure that your equipment's set up. Having automatic equipment helps with that function. Productivity obviously is a concern for every shop owner. If you have you know, 3 different types of thicknesses that you're welding with, do you do 3 separate test panels? You know, in the real world, does that happen? Due diligence, you should be doing that.
Right.
Are you getting compensated for that repair? So, you know, it's a it's a decision a shop owner has to make, and it has to be implemented in a repair plan to their technicians of what the expectations of that shop has for a proper repair.
Toby, I've also noticed when guys will have a welder that's not totally automated, and they'll make a weld and they think it's a good weld. I've seen where guys will come into the shop and hang what's called a Miyachi gauge and tell them, yes, the amperage your welder's putting out is correct.
Well, the amperage might go, but what happens when you don't have enough tip pressure?
Okay, let's talk about tip pressure for a minute. So when I have these cable welders with tong guns, it's impossible for them to put out enough tip pressure. That was another reasoning behind these new trans guns, or the big C gun with only one cable going to it. So explain how tip pressure is part of the formula to make the proper weld.
Well, that is usually what the manufacturer is going to come back at you and tell you what they want at the tip as the pressure that when you put together. What you're doing is that you're pushing pressure at the tips. When you strike that, hit your button, it's going to create that resistance there, which is going to form that weld. How are you going to form? So let's say this is your metal. Now I liquefied it, because this is a fusion weld. How do I get all this liquid together? Well, that pressure at the tip is going to push it together. And if you don't have enough pressure to force it together, then your weld will be weak. And Honda came out with a specification that they don't want MIG welding on their A pillar, B pillar, and rock reinforcement unless it is a pulsed MIG spot welder. And some of the older machines on the market that were pulsed didn't have enough tip pressure to form it. And if you wanted to use that particular piece of apparatus, you needed to put a new gun on that would create more pressure. So again, this would be specifications from what the manufacturer wants, and the manufacturer of the equipment and the manufacturer of usually work together to tell, this is what we want, you put it together, and if it does our job, then we'll put that on our program.
Now having witnessed some of the tests they do on the automatic machines, and OE before he certifies it, he'll have 1 layer of metal, 2 layers of metal, 3 layers of metal, 5 layers of metal, 1 layer of metal, and it'll just vary. But they'll take the welder and just go boom, 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 right down, never resetting the machine.
Right.
And then destructive testing, and every weld should be exactly the same. And they'll actually print out a result of what the SD card had on the machine, and it should also verify exactly what the machine said. To sum up, when we were just talking about tip pressure, an older welder without the new guns, it can't even meet the spec of a car today. So whether it doesn't have to be a sophisticated high-end car, it could be an everyday car, and it's going to require the same higher tip pressures. So if someone is going to buy a welder, it's not that the newest welders are for the elite, they're for everyone.
Good point.
Definitely agree with that. So, question I've got, and Kye, this is for you too, because I want to ask these guys from a setup standpoint. You and I know how long it takes us to set up a MIG or MAG welder, depending on what we're doing. That Toby had said that even though there's a parameter that you set in the machine, it's also that you can fine tune that per technician. Do you guys find that people just, especially on the newer spot welders, that they just flick the switch on? And again, let's assume that the surface prep is right. Let's assume that they've cleaned all 4 surfaces or all 4 surface sides up and everything's fine. Do you just see them flick the switch on and go? Just like, because again, I've seen it where folks that are MAG or MIG welding, that's exactly what happens. I mean, even on the old dial ones, they'll just flick the switch and get after it. I mean, there's no checking of anything.
Right. We do find they just flick the switch and go.
Okay.
However, we try to make it very, very clear that a welder is only as good as the power going in
Exactly.
Back to the sales and support side.
And the power is going to, in every neighborhood of the world, there's always something that can affect the power supply.
Well, and not even just the power supply. Let's assume the building power is good for just a moment, okay? What have you two seen on extension cords? And there's a reason why I'm asking, because I've been through it. It's the reason why I'm asking. But so it's an average length 20-foot extension cord. We noticed that on one side of the building, when we're not on the extension cord, the welder's perfect and it's fine. When we move it over and we have the extension cord, all of a sudden we're noticing we have to crank up the power to the welder to achieve the same thing. Do you two see that in shops you
It's
go
not
into?
coming from your extension cord, it's coming from, as a wire, as the distance starts lengthening from where your power source, the wire, there's resistance being grabbed by the wire, and when it gets over to that part of that building, there's less amperage there. And that's why you're seeing these problems. I mean, I've been in the shops where start here and go over there with one of my welders, and it was 3 different settings.
Sure.
As Dave alluded to earlier, it could depend on what else is on that circuit, how the electrician wired the shop in the beginning.
Great point.
You could have air conditioning running that day and maybe not the next. We've had instances where it blows a panel fuse, and it's, why does it only do that once in a while? Well, we had an infrared lamp that was running at the same time, and it just went over that amperage for that plug. So that you have to check all those conditions if you have variables.
And I think the key point that all of us are trying to make, especially when it comes down to electricity, is that we have to talk with their electrician. We can't just call them up, get them there, say, lay this out and go. You have to explain to them, because again, I like you were talking about certain times. I've been to OEM training where when it was hot outside, that all of a sudden I'm getting one weld. When I've been there before when it's cold, and I'm getting another with the same one, because the air conditioners, it was literally narrowed down to, they just cut the AC on. That's a huge thing that I know most people don't think of, and we have to think of. We have to now hold that electrician's hand and make sure they understand this is what this is what we have. Will this survive in the summer? Will it survive if you live where I live, where it's hot and it's hot in the summer and cold in the winter? Is it going to survive these plateaus even in fall and spring?
Right, and the on that note also, the European welders that are here, unless they were designed for our electricity, our country is 220 volts, Europe is 380 volts.
Right.
So they're going to perform much better where they're made to work.
Well said.
I will also say, look for the UL label, because it's key. That welder has gone through the proper testing in our country, and it meets the standards.
Good point. Very good point.
Hopefully, this gave you a great overview on what to look for in purchasing, in maintaining, and general housekeeping in your shop on spot welding. Again, this is the Society of Collision Repair Specialists. You can find us at scrs.com.